We talked about ternary relationships before, but ternary relationships are tough. Here we had the one we discussed where we have different renovation projects and different parts that are used in the renovation and different suppliers for those parts. We determined that we had a supply ternary relationship, and it involved three independent entity types. The supplier was independent of the part chosen. The supplier was independent of the project. The project was independent of the part was independent of the supplier, etc. So they're all three independent entity types that come together for this supply relationship. But the real question is, how do we specify multiplicity? Because you notice there's no cardinality on these diagrams. So what we would do is we would have to hold two of them constant, pair two of them together, and determine the multiplicity of the third. So let's look at supplier, like plants are us, and a part. Now for a supplier-part pairing, would that pairing be used in one project, or could it be used in more than one project? And the ficus tree from Plants Are Us could be used in many different renovation projects. So the multiplicity here for project is n. Okay, so now that we have the n identified, the cardinality nearest to project, let's pick two different entity types. Let's pick the project and the part. In this case, it could be the Robinson renovation project and the ficus tree part. And if I take any pairing of project and part, the question is, would they be provided by one supplier, or could they be provided by many suppliers? Now you might think that the ficus tree is provided by one supplier, Plants Are Us, but you have to think about every possible pairing of a project and a part. But you can't just stop at one example. You have to consider multiple examples. So here we have the project and the part. This time the part is the Aeron chair. And so for the Robinson renovation project, could I get my Aeron chair from more than one supplier? And if the answer is yes, there could be multiple suppliers of the Aeron chair for this project, then I have to put an N here. Or just to make it different, I would make it an M. So many to many. Remember, it only takes one exception for a relationship to make it go from a 1 to an M, because an M or an N means one or many. And to build a final multiplicity, we will hold the other two entity types constant. So we'll look at project, like the Robinson renovation project, and the supplier Plants Are Us. And we will ask ourselves, does the project and supplier pairing, would that pairing yield one part, or could it yield multiple parts? And the Robinson renovation project, coupled with a Plants Are Us supplier, could give us a ficus tree, but it could also give us a fake red maple tree. So if it can give us more than one potential part, then we have to come here and make this many. You'll see in some textbooks where they start using different letters, they'll use P. So M, N, and P all stand for many. I don't care if you use M, N, and P, or if you just use N, N, N. The idea is that this is now a completely filled out ER diagram with the cardinality. And you've seen how we've done it. You have to do it two at a time and pick up the cardinality of the missing entity type. Now that we've reminded ourselves of the Robinson renovation project and all of its parts, let's take a look at the data and let's take a look at how it would map to a relational table in the physical model. So let's look at step 7. Step 7 is the mapping of n-ary relationship types, like the ternary relationship we just talked about. In that, there was a relationship between parts, suppliers, and projects, but each of the multiplicities were many. So n is greater than 2 for all of the relationships. So we'll make a new table called supplies, and that table will represent the relationship. And then there will be as many foreign keys as there are entity types in the relationship. So we have the project ID, which is a foreign key to the project ID in the project table. And we have the part ID, which is a foreign key to the part ID in the parts table. And we have the supplier ID, which is a foreign key to the supplier ID in the suppliers table. And then altogether, these three form the primary key of this relationship in this table. So I need all three foreign keys together to be a composite key. Notice that's true because, as you can see here, my Robinson renovation project, the Aeron chair, I got 7 of them from supplier 1. But then I turned around and for the Robinson renovation project in the same Aeron chair, I had to pick up an additional one from supplier 2. So altogether, I got 8 Aeron chairs, but I used 2 different suppliers. This is why I need all 3 elements to be the primary key. Let's try another ternary relationship. Here we'll talk about keeping track of COVID vaccines. And so we have patients, and we have physicians, and we have the vaccine. And these are all taking part in the vaccinate relationship. So let's try to identify the cardinality. First, we will start with a patient and a vaccine. And so if we have a patient and a vaccine, will there be one or could there be more than one physician? And the answer is, yeah, there could be more than one physician, so we're going to put a many here. There could be more than one physician because you need 2 shots of this vaccine. So I may have gotten the Pfizer vaccine from Dr. X, and then 3 weeks later gotten the second vaccine shot from Dr. Y. So that's why that would be an N. Now, let us do the same thing with the other combinations. Let's take a look at the physician and the vaccine. So the physician and the vaccine, this is pretty obvious. That combination is going to be involved with multiple patients, hopefully a lot of patients. So this would also become many. Fine. Now let's take a look at the last combination, which would be a patient and a physician. So if I'm a patient and a physician, I am going to get only one vaccine because I would never have, for a physician-patient combination, 2 different vaccines. If I start with Pfizer, I end with Pfizer, my second shot. If I start with Moderna, I end with Moderna. So any combination of a physician and a patient is only going to ever have one shot. And so this ternary relationship looks like an M to N to 1. We'll see how we model that. It'll be modeled exactly the same way with just one slight difference. Notice that in the case of the COVID vaccination example, we build our bridging table the same way. Again, we're bridging 3 entity types. And so you will see that we have the patient ID, which is the primary key of patient. We have the physician ID from physician, and we have the vaccine ID from vaccine. So we have 3 foreign keys in this table. But now what we say is that the table of the 1 does not need to take part as the primary key of this table. So if I'm looking at the primary key, right now I would be looking at the patient ID and the physician ID, and definitely not the vaccine ID. But that's not the end of the story. If those 2 attributes are part of the primary key, they cannot be the complete primary key, because patient 1 could have seen physician 24 the second time in March. So what I need to do is I need to bring my primary key, I have to include the date as part of it. And when I include the date, along with the patient ID and the physician ID, then I will have a primary key. So the mapping is exactly the same. The strategy is exactly the same. I still have 3 foreign keys, but I might have a different primary key. And again, the entity type with a cardinality of 1 will not be a member of the primary key of this table. Here's another example I want to leave you with, a reservation at the 3 Beer Comedy Club. When you make a reservation for a particular date, it involves a patron, and the reservation requires that you purchase a sandwich, you pre-order your sandwich, and that you pre-order 3 drinks. 3 different beers, obviously. So again, the patron, the drink, and the sandwich all come together in a ternary relationship. If you examine these carefully, you will deduce that there should be a many on all 3 of those entity types. So what would you do? Again, you would build a bridging table. The table would be called reservation. You'd have a patron ID, a drink ID, a sandwich ID, and then you would have the reservation date. Now, I wish I could tell you that following these rules is all you need to have a physical database that is correct. But we're going to learn later that it gets you most of the way there. There's something else we have to talk about called data normalization. And it turns out that our 3 Beer Comedy Club, if we follow the rules and if we follow step 7, we'll have a database that is not normalized, and we would have to change it up a little bit. But for now, relax in the fact that you can take all 7 steps and you can convert a conceptual ER diagram into a physical data model.